Section 1.3, number 1. Here we're asked to figure out which numbers from this following list of numbers is a rational number. So before we do that, let's talk a little bit about what are the different number types to choose from, because this problem messes up a lot of students, so I want to make sure you're all pretty clear on what are the number sets in the first place. Alright, so first we start with the natural numbers. Now the natural numbers are just the numbers you would use to count with, the counting numbers. 1, 2, 3, 4, going on forever to infinity. We don't include 0 because we don't count with the number 0. Whole numbers would come next. The whole numbers are all of the natural numbers or the counting numbers, and then include 0. So now we have 0, 1, 2, 3, goes on forever. Integers, and you'll notice that the whole numbers included everything above it and then added something in. Same with the integers. Integers include all of the whole numbers, 0, 1, 2, 3, going on forever, and negative whole numbers. So going in the opposite direction, negatives to negative infinity. So we have negative 2, negative 1, 0, 1, 2, going forever in both directions. Rational numbers. Once again, they include everything above it, so they are integers, and they are also the numbers between integers. So that would be any number that can be expressed as a ratio of integers. And the way I always remember that rational numbers can be expressed as ratios or as a fraction is that the word rational starts with the word ratio. So if you have a number and it can be expressed as a fraction, then it's going to be a rational number. So for example, minus 3/4. That is a ratio of integers. It's a rational number. The number 5, if it wasn't written as a fraction, well, you can always write a number as over 1. So 5 would be a rational number. Root 4. Any root that's a perfect square, root 4 equals 2, is a rational number because 2 is the same as 2 over 1. If you have a non-perfect root, such as root 7 or something like that, that is not a rational number because you cannot write its result after you do the root as a fraction. For decimals, any decimal that ends or has all zeros to the right can be written as a ratio of integers. 0.5, for example, is 5/10. So that'd be 5 over 10. So any decimal that ends or has all zeros on the end can be written like that. Also, any decimal that repeats forever can be written as a ratio of integers. So for example, 0.6666 going forever, which is 0.6 repeating, is 2/3. So any decimal with a repeating pattern is a rational number. Irrational numbers are any numbers that are not rational. And the trick is, how do you identify irrational numbers? And usually what I do is I look to see, first of all, do I have a non-perfect root? If I do, I've got an irrational number. As far as decimals, do I have a non-repeating decimal pattern? So for example, I have here 0.242629. There's definitely a pattern, but it's a non-repeating pattern. Therefore, it's irrational. To be a repeating pattern, it would have to be something like 0.242424 going on forever. Then it would be a rational number. The real numbers are all of the above types. So all rational and irrational numbers make up the real number system. All right, so let's keep those definitions in mind and pick out the rational numbers from this list. So again, what we want to do here is pick out any number that could be written as a ratio of integers. And then it will be a rational. So minus 12, yes, because I could write that as minus 12 over 1. 0, yes, I could write that as 0 over 1. 90, yep, 90 over 1. 9.74, the decimal ends. So if I wanted to, I could say 974, and the decimal goes to the 100th place. So I could say 974 over 100. So any ending decimal is a rational number. Root 5, non-perfect root, not rational. Root 9, yep, that's just a 3. So root 9 is a rational number. 1.5, well, 1.5 is the same as 3 halves. So any mixed number can be rewritten as a ratio of integers. So it's rational. Minus 13 over 11, that already is a ratio of integers. It's rational. And then this decimal we have over here, 1.15155, and I ran out of room, but the actual number in my math lab question then keeps going 1555. And what we have is a pattern, but it's not a repeating pattern. So that's not included in the rationals. So this list right here would be the rational numbers. And just be careful when you're inserting these into the My Math Lab answer box. Right here, when you get to the root, make sure that you end the root. So you're going to have to hit the template button that has the square root function, turn it on, and then put the 9 inside it. Then click on it again to turn it off, and that's going to make it end. Then put your comma. If your comma ends up here inside with the 9 under the root, it's going to score your answer wrong because it's not going to recognize that as the root of 9. So that is classifying numbers.